An operating system. An operating system is an interface between a computer user and a computer hardware. An operating system is a software which performs all basic tasks like file management, memory management, process management, handling input and output, and controlling peripheral devices such as disk drives and printers. Some popular operating systems include Linux operating system, Windows operating system, VMS, OS 400, AIX, ZOX, etc. Basic functions of operating systems are process management, memory management, managing device and file systems, networking, and security. Function number 1. Process management. Every program running on a computer, be it background services or application, is a process. Modern operating systems enable concurrent execution of many processes at once via multitasking even with one CPU. Process management is the way of operating systems dealing with running multiple processes. Since most computers contain one processor with one core, multitasking is done by simply switching processes quickly. Process management involves computing and distributing CPU time as well as other resources. Most operating systems allow a process to be assigned a priority which affects its allocation of CPU time. Interactive operating system also employs some level of feedback in which the user receives higher priority. Interrupt-driven processes will normally run at a very high priority. In many systems, there is a background process such as the system idle process in Windows, which will run when no other process is waiting for the CPU. The services provided through process management are very important if the operating systems support multiple users. In a multi-user system, at any given time, the CPU can execute only one instruction belonging to any one of these programs competing for the CPU. The function of the operating system in this regard is to keep track of all the competing processes, schedule them, and execute them one after the other. But while doing so, try to give each user an impression that he or she has the full control of the CPU. Function number 2. Memory management. Memory management deals with allocation of memory and other storage areas to the system programs as well as user programs and data. The services provided under memory management are directed to keep track of memory and allocation. Current computer architectures arrange the computer's memory in a hierarchical manner, starting from the fastest registers, CPU cache, random access memory, and disk storage. An operating system's memory manager coordinates the use of these various types of memory by tracking which one is available, which is to be allocated or deallocated, and how to move data between them. Another important part of memory management is managing virtual addresses. If multiple processes are in memory at once, they must be prevented from interfering with each other's memory unless there is an explicit request to utilize shared memory. This is achieved by having separate address space. The operating system can also write inactive memory pages to secondary storage. This process is called paging or swapping. The terminology varies between operating systems. It is also typical for operating systems to employ otherwise unused physical memory as a page cache. Requests from data from a slower device can be retained in memory to improve performance. The operating systems can also preload in the memory cache with data that may be requested by the user in the near future. Superfetch is an example. Function number 3. Networking. Most of the currently used operating systems are capable of using TCP or Transmission Control Protocol or IP Internet Protocol. This means that one system can appear on a network of the other and share resources such as files, printers, and scanners using either wired or wireless connections. They also support one or more vendor-specific legacy networking protocols as well. For example, SNA, System Network Architecture on IBM system, DECnet on systems from Digital Equipment Corporation, and Microsoft-specific protocols on Windows. Device and file system management. All operating systems include support for a variety of file systems. Modern file systems comprises a hierarchy of directories. While the idea is conceptually similar across all general-purpose file systems, some differences in implementation exist. The file system is intended to provide a convenient management of information so that the user is free from the problems related to the allocation of space for the information as well as other physical problems such as the storage format. Thus, the user need only to deal in terms of the logical structure and the operations performed on this information. File systems may also offer the ability to share information among users and protect information from unauthorized access. Function number 5. Security. Security refers to providing a protection system to computer system resources such as CPU, memory, disk, software programs, and most importantly, data or information stored in the computer system. If a computer program is run by an unauthorized user, then he or she may cause severe damage to the computer or data stored in it. So, a computer system must be protected against unauthorized access, malicious access to system memory, viruses, worms, etc. We are going to discuss the following topics later. Securing aspects: authentication, one-time passwords, program threats, and system threats. Authentication. Authentication refers to identifying each user of the system and associating the executing programs with those users. It is the responsibility of the operating system to create a protection system which ensures that the user who is running a particular program is authentic. It is usually carried out in the following ways: username or user password, user card or user key, user attributes like fingerprint, iRetina pattern, or signature. One-time passwords. One-time passwords provide additional security along with normal authentication. In one-time password system, a unique password is required every time the user tries to log into the system. Once a one-time password is used, then it cannot be used again. One-time passwords are implemented in various ways. Number 1. Random numbers. Users are provided cards having numbers printed along with corresponding alphabets. Systems ask for a number corresponding to few alphabets randomly chosen. Number 2. Secret key. Users are provided a hardware device which can create a secret ID mapped with user ID. System asks for such secret ID which is to be generated every time prior to login. Number 3. Network password. Some commercial applications send one-time passwords to user on registered mobile or email which is required to be entered prior to login. Securing aspect number 3. Program threats. Operating system processes and kernel do the designated task as instructed. If a user program made these processes do malicious tasks, then it is known as program threats. One of the common examples of a program threat is a program installed in a computer which can store and send user credential via network to some hacker. Following is the list of some well-known program threats. Number 1. Trojan horse. Such program traps users' login credentials and stores them to send to malicious user who can later on login to computer and can access system resources. Program threat number 2. Trapdoor. If a program which is designed to work as required have a security hole in its code and perform illegal action without knowledge of user, then it is called to have trapdoor. Program threat number 3. Logic bomb. Logic bomb is a situation where a program misbehaves only when certain conditions meet, otherwise it works as a genuine program. It is harder to detect. Program threat number 5. Virus. Virus, as name suggests, can replicate themselves on computer systems. They are highly dangerous and can modify or delete user files, crash systems. A virus is generally a small code embedded in a program. As user accesses the program, the virus starts getting embedded in other files or programs and can make system unusable for the user. Securing aspect number 4. System threats. System threats refers to misuse of system services and network connections to put users in trouble. System threats can be used to launch program threats on a complete network known as program attack. System threats create such an environment that operating system resources or user files are misused. Following is the list of some well-known system threats. System threats number 1. Port scanning. Port scanning is a mechanism or means by which a hacker can detect system vulnerabilities to make an attack on the system. Number 2. Denial of service. Denial of service attacks normally prevent users to make legitimate use of the system. For example, a user may not be able to use internet if denial of service attacks browser's content settings. Number 3. Worm. Worm is a process which can choke down a system performance by using system resources to extreme levels. A worm process generates its multiple copies where each copy uses system resources, prevents all other processes to get required resources. Worm processes can even shut down an entire network.